Hello everyone, this is problem E of Educational Codeforces round 148. In this problem, we are given an array A and an integer k, and we have to calculate a new array which is B and which is denoted using this formula. All the Bi's are denoted using this formula. So, which is B of I equal to B of I is equals to sum from 1 to I minus j plus 1 choose k times aj, and this value needs to be taken modulo this mod number. So, to solve this problem, we need to simplify the given equation a little bit. So, let's try to simplify it. To simplify it, we'll need a property of combinatorics, which is n choose r is equals to n minus 1 choose r minus 1 plus n minus 1 choose r. So, using this property, let's simplify it. So, this is how we can simplify this part using this formula, and aj is multiplied with both of them. So, we will write aj here, and this sum is independent for these two parts. So, this sum can also be taken for these two parts. So, let's do this. So, let's write it here first. So, if we write the equation like I minus 1 minus j plus 1, then this minus 1 and this plus 1 will cancel out and we'll get I minus j. So, it will remain the same. So, we can write it like this, and let's also write this equation like that. We'll separate out I minus 1. Yeah. So, now if we take a look, this equation and this equation, in place of I, we have I minus 1 here, and the sum goes up to I. So, if we take the sum up to I minus 1, and we can separate out j equals to I. So, let's write j equals to 1 to I minus 1 minus j plus 1, and we need to write j equals to I separately. If j is equals to I, then I minus 1 minus I plus 1 choose k times aj, and we'll do the same thing for this. We'll take the sum up to I minus 1 and we'll write j equals to I separately. So, if j is equals to I, then we get minus I. This times aj. So, now this part of the equation is exactly same to this. just in place of I we have I minus 1, so we can write this as b of I minus 1 plus, so this I and I cancels out, and minus 1 and plus 1 cancels out, so we have 0 choose k. So we have 0 choose k, where k is at least 1. The value of this is equals to 0. So 0 times aj will be 0, so we will not write it here. And if we check this value, this is also exactly the same as b of I, but in place of k we have k minus 1 here. So we can say that this is also b of I minus 1, but which is calculated with k of k minus 1, and this was calculated with k, and what we want to figure out is b of I which is calculated with k, plus this part. So here also I and minus I cancels out, and minus 1 and plus 1 cancels out, so we get 0 choose k minus 1 into aj. So one problem is here, the minimum value of k can be 1, and if the value of k is 1, then we get 0 choose 1 minus 1, which is 0, and this is equal to 1. But if the value of k is greater than 1, then we will get 0 choose some value here which is positive, so the value of this is 0. So we don't need to worry about this case because this gets multiplied with 0. But if the value of k is 1, then we will get a 1 here, then the contribution for that will be 1 into aj. So 1 into aj, which just means aj, but when will we get this? We will get this when k is equal to 1. So this is one edge case that we will have to consider. So let's write the full formula. P of I k equals to P of I minus 1 k plus P of I minus 1 k minus 1 plus, yeah. So this is the full formula. This is a recursive formula. So this can be solved using dynamic programming in O of n into k time. So to solve this, we just need to figure out the base cases. So the base cases are also pretty easy to figure out. So let's say b of the base cases are b of I 0 and b of 0, let's say L. So if we need to figure out, so let's write the formula of P of I once again. The value of k is 0. So something choose 0 is 1. So this is just sum from 1 to I page. So this is just the prefix sum up to index I. This is the value of B of I 0. And what is B of 0L? Again, using the given formula, we have I minus j plus 1 choose L. So the value of I here is 0. So if we write it like this, this will be, so into aj. So this is some value. So the value of minimum value of j can be 1, and it can also be greater. So it will be some negative value choose L, or it can be 0 choose L. So both of these equal to 0. So in both these cases, the formula will be 0 times aj. So it will be equal to 0. So B of 0L is equal to 0. So now that we know the base cases, we can use dynamic programming to solve this problem using this recursive formula. And we might also want to use space optimization here, because the value of n can be really large, n can be up to 10 to the power 7. So 5 into 10 to the power 7 memory, it might pass, but it is not optimal to do that. Yeah, that was it. Thanks.